I'm Anil Kumar sharing with you a multiple choice question on even odd symmetry of functions. The question here is, which of the following is or are true about symmetry of a function? A. Even degree function is an even function. B. Odd degree function is an odd function. C. Product of even and odd function is an odd function. And D is, a function cannot be both even and odd. I would like you to pause the video, answer this question, and then look into my suggestions. Now, when we are talking about even and odd degree functions, we are referring to polynomials, right? So I should have mentioned even or odd degree functions related to polynomials. Right? So both these points are actually related to polynomials. So in general, a polynomial can be written as an x to the power of n plus an minus 1 x to the power of n minus 1 and so on, like a1x plus a0. So n is the degree of polynomial, right? So in this case, n is degree of polynomial. So in general, when we say even degree function is an even function, we are referring to polynomials. Okay. Now answer these questions and then check with my solution. I've seen many times students making mistake here. Remember, you could have more than one answer as correct in this particular case. Now, before we begin to answer these questions, let's try to understand what even symmetry is and what is odd symmetry. So what is even symmetry? Even symmetry basically means that if I sketch a function, then it is symmetric about y-axis. So a function being symmetric about the y-axis, that means we have a mirror image. Do you see that? So that is even symmetry. Algebraically, you can say whenever f of minus x equals to f of x, function has even symmetry, right? Now what is odd symmetry? Odd symmetry is when a function is symmetric about origin, right? So kind of function like this. Now a cubic function, for example, is symmetric about origin. That is odd symmetry. Algebraically, we could write f of minus x equals to negative of f of x. The other examples could be 1 over x, for example, right? So that is an odd function. Just as we could have a function which is x cubed plus x. That is also odd function. The other examples here could be x to the power of 4 plus 3x squared plus 2. Now these are odd functions. If you do f of minus x, these are all even functions. If you do f of minus x, all these powers will make the coefficients same, and so it will be equal to f of x. In this case, negative power will be negative, so you get negative f of x. Correct? Now with that in mind, I'd like you to answer these questions, right? So let me provide you with the solution first, and then we will see how to justify them. The first one here is even degree function is an even function. This statement is not true. This statement is false. Similarly, odd degree function is an odd function is also a false statement. We will see into this with examples. Statement C, which is product of even and odd function, will verify, and D is A function cannot be both even and odd. We'll see if some examples exist. Okay, so let's explore the first two criteria first. So let us take a function, let us say f of x, which is x squared plus 2x minus 1. Now this is even degree, right? Degree being 2. What is f of minus x? F of minus x is minus x squared plus 2 times minus x minus 1. That gives us x squared minus 2x minus 1, which is not equal to f of x. Therefore, it is not an even function. Is that clear? So A is false. Correct? Now let's look into B. Let's take an odd function. So we'll take an example like x cubed plus, let's say plus 1. Now what is f of minus x equals to? F of minus x is minus x whole cube plus 1, which is minus of x cubed plus 1. Now this is not equal to negative of f of x, correct? Negative of f of x is both negative, but this is not both negative. And therefore, we know that odd degree may not be or may not have odd symmetry. Correct? So we have shown that even degree function may not have even function, may not have even symmetry. Similarly, we have shown that odd degree function may not have odd symmetry, right? So I think I have proved A and B. Now let's look into the product of even and odd, right? So for product, let's take an example which is a trigonometric function. Let's take a function f of x equals to sine x times cos x. Now, as you know, sine x is odd function, right? Let me sketch here. Sine x could be sketched like this. Now, in this case, we know that sine of minus x equals to minus sine x. So it's an odd function, odd symmetry. On the other hand, cosine x is, let's sketch it here. Correct? Now for cos x, we know cos of minus x equals to cos x. Do you see that symmetry? It is even symmetry. But here we have product of these two. So we have product of odd times even. What do we get? Let's check. So to check, we'll find f of minus x, which will be sine of minus x times cos of minus x. And sine of minus x is minus sine x. Cos of minus x is cos x, which just gives us negative of this, which is same as negative of f of x. Therefore, it is odd symmetry. Correct? So we have an example which does illustrate that product of even and odd is basically odd symmetry, right? So coming back to our original question, we get C as true. Now how about D? A function cannot be both even and odd. How do we answer that? Do we have some examples? Yes, we do. Let's look into D, which is function which has both even and odd symmetry. The best example is f of x equals to 0. Now what is f of x equals to 0? Well, f of x equals to 0 is the x-axis, right? Now this x-axis has both symmetries. It is symmetric about the y-axis plus about the origin. Do you see that? So f of x equals to 0 is having both symmetries. So here f of minus x is equal to f of x, and which is also equals to minus of f of x. And therefore we do have function which has both the symmetries, right? Which is f of x equals to 0. So this statement is false. Our function cannot be, right? Cannot be. So we have provided you with an example. There is a function f of x equals to 0 which has both symmetries. So I hope with this you have clear understanding of even and odd symmetry. Feel free to write your comments and share your views. And if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.